This function is called the greatest integer function. The equation for this one is f of x is equal to, and then this symbol is a little bit weird. It's like a bracket with an extra bar on it, and then a closed bracket with an extra bar on it. And this is read the greatest integer of x. Now, in order to truly understand this one, I want to talk about this greatest integer thing for just a moment. So I'm going to put this to the side and bring up some paper. Now, first of all, an integer is just a positive or negative whole number. So it includes all of the whole numbers. So that would be numbers like -2, -1, 0, 1, 2, 3, 4, etc. So that means the output of this function, the y values of this function, are all going to be these types of numbers. And it goes on forever in each direction. So here's how this function works. For whatever I take and put inside these bars, like let's say I take a 2, the output of that is going to be the greatest integer that is a part of this number. Now 2 is an integer itself, so the greatest integer that's a part of that number is actually 2. If, however, I pick something that's a little bit bigger than 2, like maybe 2.1, then the greatest integer, greatest whole number, positive or negative, that is a part of this number is still 2. If I pick something a little bit bigger still, like say 2.4, then the greatest integer that's a part of that number is still 2. And if I pick something a little bit bigger, like 2.7, well, the greatest integer that's still a part of this number is still 2. And I would continue to get 2 for any number that I pick to put inside the greatest integer between 2 and 3. So I could even pick, say, 2.9999. And the greatest integer that's still a part of this number is still 2. But when I go just a little bit bigger, so if I go to 3, well, now the greatest integer that's a part of this number is 3. And then if I did 3.1, I would still get 3. If I put in 3.4, I'd still get 3. If I put in 3.7, I'd still get 3. If I put in 3.9999, I'd still get 3. But if I put 4 in place of the x, then suddenly I would get 4. So let's see what this looks like on the graph. I'm going to zoom in a lot. We're not going to use the table on this one. We're going to use the information that we just got. I'm going to zoom in on this graph here. The points that we got there were 2 went with 2. So starting at 0, I'd go over 2 and up 2. And then we said 2.1 was one that we used, and we got 2. And 2.4, so that'd be over about here. We still got 2, and we continued getting 2 for everything in here until we got to 3, and then all of a sudden at 3, it jumps up to a y value of 3. Now the way we indicate this, that it's getting as close as you can possibly get to this x value without actually getting there, is we put an open circle there. So we'd have a closed circle on this side. It would include all the y values in between those two, but then once you get to 3, it jumps up to the next level. And then for every value between 3 and 4 here, you would get 3 as a result until you got to 4, but you'd have to say not including the 4 there, because once I get to 4, it's going to jump up to the next level, and the y values will now be 4. So with this, I can I can kind of get an idea about what the graph looks like. It's going to continue this pattern, so it's going to jump up to the next level here, and it'll jump up to the next level here. And I'm out of levels on this side, so I could continue to pattern backwards now. So if I wanted to continue the same thing, I would have to jump down a level. I'd have an open circle there, closed circle on that side, jump down a level, open circle here, closed circle, jump down a level, open circle, closed circle, jump down a level, open circle, closed circle, down, open, closed, down again, open, closed, down again, open, closed, down again, open, closed, and then I can do it one more time to fit on the grid that I have to work with here. And this pattern would actually continue on forever in both directions. So this is what the greatest integer function looks like when it's graphed. All right, so we're skipping over this part here. We kind of took care of that on the previous page so that we could get an idea about what was happening on the graph, and then we just generalized, recognizing the pattern there. So now for the domain, the x values that we're allowed to use, the numbers that we're allowed to put in here in place of x, is any number at all. So we could put in any number between negative infinity and infinity. So that would be any real number. The output, however, the y values on this, are a very specific set of numbers. It's not just any number at all. The numbers that we get out are always positive or negative whole numbers, also known as integers. So we have a symbol for integers. We'd say that the y belongs to the set of integers, and that symbol is a z here with kind of a double bar in the middle, kind of a fancy looking z. All right, now for intervals of increasing, decreasing, and constant. So if I put my pen on the graph as far to the left as I can see, and I move it along the graph, I'd have to stay at a constant level for this little step here. And then I would have to pick up my pen to get to the next level. And then I'd stay at a constant level for this step. And then a constant level for this step. And a constant level for this step. So I need to find some way to indicate that it's going to be constant from this number to the next whole number. But then it's going to jump and be constant then from the next whole number to the next whole number. And this is all constant, so I'm going to be writing this over here. So what I'm going to write here, I'm going to use k to represent a number. Specifically, a real number. So that's any number that you know, positive, negative, fractions, decimals, irrationals, any of those. So k is any number. Sorry, that's not right. K has to be an integer. So any integer. And if I wanted to say that it's going to be constant from any integer to the next integer, then I could express that by saying it's from k, one integer, to k plus 1. That would be one number bigger. And then I put that in parentheses. If I want to indicate that k has to be an integer, then I would say for k belongs to the set of integers. Now this would encompass the entire domain, so that means this function is never increasing and it's never decreasing. It is always constant. What you need to know about the greatest integer function is you need to know the name. You need to know the equation. You need to know the graph. This graph is sometimes called a step function. You need to know the domain and the range.